All right, guys. So I am especially recording this for those students that will be going to other classrooms. And if you're not part of intervention, you need to be watching these videos, filling out this booklet, and then working on your review. Make sure you turn it in the next day, 2 days late, or day after the next day. So this one will be due, the packet that goes along with this one, with this foldable, will be due on Wednesday. If you turn it in on Thursday, it's 70. Friday, well, we won't be here Friday. If you turn it in Monday, it'll be a 60, and so forth. Okay. So with radicals, exponents, functions, and sequences. Radicals, anytime, one of the most helpful tricks that I'll be able to show you is within this packet. This one, and there's also going to be another one that we're going to see on Thursday. So anytime you see the words equivalent expression or find an expression equivalent to, big keyword. A lot of questions in the STAR test have those two words. Which expression is equivalent to, so forth. Now you're going to have different tricks that you're going to use for different problems, but with this one of the things you could do is you could type square root of 184 into your calculator. So let me detach on. Clear whatever I have here. Second, square root of 184. And get the decimal value, which is 13.56. Okay. And then you also want to type in the answer choices one at a time to get their decimal values. My bad. So obviously 92, if I type 92, it's going to give me the same exact answer. So I'm going to go with B, 2 second square root of 46. And what does that give me? 13.56. So far, so good. But you always want to make sure, double check everything else. So 4 square roots 23. You get 19.18. Sorry. 19.18. And then 4 square roots of 46. 4 square root 46. And you get 27.12. Don't worry about rounding as long as you're able to see in general, get close enough to it, 27.12. And then you'll notice this one matches this one, 13.556. So your answer choice is B. Those two are equivalent, they're equal. Now, laws of exponents were always super confusing. One of the things with laws of exponents, you had to know how to read your formulas. These are the formulas that are included with laws of exponents. It's the second section in the formula chart. So you always want to be able to compare them. If you're multiplying two bases or multiplying two variables with two separate variables, but the same variable, you're going to add the exponent. You're dividing those two variables, you're going to subtract the exponent. If you're taking one variable and you have two exponents attached to the one variable, that's when you multiply those exponents. One base raised to 2 powers. And then converting back and forth from exponent to radical form. Remember, E over I, E comes before I, so exponent over index, and exponent is in the same spot that you would normally see it, right next to the variable, okay? And then quotient rule, cross the line, change the sign. But, negative exponent, use the quotient rule first. You always want to subtract first before you do any switching. It's always easiest when you subtract first, okay? But with this one, there is a trick that we can show you. And because you're going to have your calculator reset the day that you receive it on the STAR test, you have to do this part first. So first thing you want to do is you want to rewrite and change all of your variables to an X, including the problem in the question. So notice here, instead of X and Y, we have now X and X. 3XY became 3XX. And I did the same. I went ahead and did the same with all of the other examples with the answer choices. You can do this with fractions. You can do this with problems that look like this, whatever. But you do have to, because this calculator will be reset, you're going to have to store the X as 1, meaning you're going to press, look at step 2, store X as 1. You're going to press the number 1, store X, and then press enter. So push the number 1, store right here above on, and then X. So that means you want to substitute every single X with the number 1 and then press enter, and it'll look like that. Nothing else. From there, now you get to type everything in the home screen and get the values just like we did with the previous example. So I'm going to type all of this in. Remember, to type in any type of fraction, you use alpha y equals. So at the top, we're going to have 36 x to the power of 4, x to the power of 5, because you cannot type in any type of y. So that's why we're changing everything to an x. 3xx and squared. There we go. And that gives us the answer 4. So now I want to see what all of my other answer choices get. The ones that end up matching are that's going to be my answer. So I'm going to type in A into the calculator. Why can't I make this smaller? I don't know. All right, so 12 x to the power of 3. Oh, delete, x to the power of 3, x to the power of 4. And we get 12. Looks next one, 27 x squared, x to the power of 3. That one gives us 27. 4 x squared, x to the power of 3. That one gives us 4. And then we also get 6 x to the power of 3 and x to the power of 4. That one gives us 6. So let's write those numbers down. The first one gave us 12 when we typed it in. Next one gave us 27. This one gave us 4. And this one gave us 6. So our answer would be the 4. These two are equivalent. Okay. Functions. Functions are pretty straightforward. They're pretty simple. Just remember, you focus on the X value. You want to make sure, you want to double check to see if it repeats or not. So I went ahead, pro tip, scratch out the Y values. I went ahead and scratched out all of the Y values, and I showed you tables where if it repeats, it's not a function, does not repeat, it's a function. So notice how -13 is repeating over and over. So that's why it's not a function. 1, 3, 7, 12, neither of those numbers are the same. So if it does not repeat, it's a function. -1, -1, that repeats, not a function. -9, 0, 1, -3. Neither of those numbers are the same. So it doesn't repeat, not a function. I went ahead and I also I put a little gray box over it. The reason I did, I wanted you to still be able to see the number, but typically you would just scratch out the Y values so you're not tempted to look at those. You only want to look at your X values. Maps, I always tell everybody, my students, especially, that it's easier. It's so much easier to just convert it into a table. 2 is pointing to 20, but it's also pointing to 40. So 220, 240, 3 goes to 30, and then 4 goes to 40. You see here that the 2 repeats. So this would be not a function. So much easier to see it once you separate the numbers and you're not busy trying to look at arrows. I know a lot of teachers like to teach, you can't have 2 X's, something like that. I never understood that. So here, you convert it to a table, neither of your X values repeat. You always want to scratch out the Y values. So you'll notice that neither of those repeat. With graphs, you want to use the vertical line test, meaning you're going to draw a vertical line going through the function. There are discrete and continuous graphs, meaning you have some graphs that have points that are not connected, but some that are. if I were to draw a vertical line through each one of these points here, you already have one that's drawn through that point. But let's say I draw it through this one, this one, this one, and this one. Either one of those vertical lines are gonna only cross one time. Here, I draw through this one, it crosses once, crosses once, crosses once, but here in this last line, it crosses 2 points. Because it's crossing 2 points, this is why this one is not a function. This graph would not be a function. This is representing an X value that repeats. If you were to identify those points, that would be 3, 1, and also 3, -2. 3, -2. So notice your X value is repeating. Look at a continuous graph. It doesn't matter where I draw a vertical line, it's only going to cross one time. Here, it'll cross twice every single time. There and there. Maybe I should make it a different color. There and there. Here, it's only crossing one time. So when in doubt, you want to also check to see if the X value repeats, period, and then just pick the odd man out. If you have 3 functions or 3, say you have an example that has a graph, a table, a map, and ordered pairs. 3 of them have X values that repeat and 1 that doesn't. That one that does not repeat is your answer. If you have 3 functions where the X value does not repeat and only 1 of them repeats, that would be your answer. So always try that one as well. Pick odd man out. Function notation. Function notation is all about plugging numbers in. You're just plugging numbers in. Anytime you see f of x or f of 6, the x is in the same spot as the 6, so they're equal, they're identical. You can change them, you can swap them out. So I would rewrite the equation, replacing every x, which also could be a g, n, p, anything, with the number in the parentheses. I like to keep any substitute numbers in parentheses just in case there are any negatives. If the number is in parentheses, and if you're substituting any number, keep it in parentheses because the negatives do make a difference if you leave them out of parentheses. Okay, and then type the new equation into the calculator and there's your answer. Just don't forget math enter if you need to change anything to a fraction. So look at this example that we're given. Given p of x is equal to -4 times x minus 15 squared plus 2. What is the value of p of 7? You notice that the 7 and the x is in the same spot. So we're going to replace any x with a 7. And notice once again, I keep that in parentheses. So I put all of this right here into my calculator and I get my answer, -254. -254. Next page. Here's another one, but it can be given. It says, when working with word problems, pay very close attention to what is given and then substitute in the correct spot. So look at this problem. It says the baker determined the annual profit in dollars from selling pies. It gives you the equation. N is the number of pies sold. It says, what is the annual profit if the baker sells 400 pies? So if N is the number of pies sold and they sell 400 pies, then 400 is N. So I rewrite that equation and substituting any N, you see N in 2 spots here with the 400. You only substitute that, everything else stays the same. Notice I kept the squared in the same spot. And when you do so, you'll get your answer, which is in this case, 12,800. And that would be your answer choice. Last but not least, sequences. For my class, sequences is something that I did not have time to teach this year, but It's not something that is more likely to be tested. It's more than likely not going to be tested. Just in case, I'm going to show you a trick to be able to solve these. You have equations. All of your equations are all of your answer choices are in equation form. So one thing you can do is you can create a table out of them. You can create an X and a Y table out of these, X and Y. Okay. Now notice it says make a table from the values given. First number is your X value of 1, second number X value of 3. But here you see A of N, right? Everybody sees that A of N right there. Every equation in my answer choices has an A of N. N is your X. If you look at the calculator, you'll notice that X and N are in the same button. So they're the same thing. N is X. So here we're saying that if we plug in a 3, we get a 0 as a Y value. So 3, 0. 3 is the next value, 4 is the next value, 5 is the next value, 6 is the next value. So 4, 6. I plug in a 5, I get a 12. Plug in a 6, I get an 18. 6, 18. And we also have this one over here, 7, 24. Since my equations are already solved for Y, since everything's ready, I can type that into Y equals. I can type each one into Y equals and compare it to the table I'm given. So the first one is negative 6N. I'm going to just click that N and it still changes it to an X. That's okay. 18, press second graph to look at that table. And there you see 3, 0, 4, negative 6, negative 12, negative 18. So this equation, this answer choice does not match. Let's try the next one, negative 18N. Negative 18N plus 6. Second graph. 3, negative 48. Doesn't match even in the first one. Next one. 6N minus 18. Second graph. 3, 0, 4, 6, 5, 12, 6, 18. 3, 0, 4, 6, 5, 12, 6, 18. Here we have one that may be it. And you always want to double check that last one as well. 18N minus 6. Second graph. 348 doesn't match even from the first point. So your answer is H. Or you could be given a problem where they give you the equation, but you have to find the sequence that goes along with it. So with sequences, the only thing you want to do is you want to check the equation. If you're given the equation in the problem, check to see if there's an addition or subtraction sign in the equation, in the right side of the equation or whatever, in the right side of that equal sign. And if there isn't a plus or minus sign, ignoring this part, if there isn't a plus or minus sign between the 4 and the A, then no, that means you are multiplying. So this is representing 4 times A, 4 times A, 4 times 4, times 4. So that means I'm taking that very first number and multiplying it by 4, multiplying it by 4 again. It's giving us that very first number, which is 6. Now, if you look at your answer choices, all of them start with the 6. So we're just going to look for the sequence or the pattern that's multiplying by 4 every time. So 6 times 4 gives me 24. I'm actually going to put it in parentheses because I don't want y'all to think it's a decimal. Times 4, 96. Times 4, 384. So here we are multiplying. 6 to 10, what are we doing here? We're adding 4. 10 plus 4 gives me 14. 14 plus 4 gives me 18. So we're adding 4 here. Cannot be B. And there is no way for me to get from 6 to 20. unless I add what, 14 plus 14. But if I add 14 again, I don't get to 100. So this is just not a sequence, not a sequence, not a pattern, if you will. Same thing, plus 14, not going to happen. So this is not a sequence. And your answer is A. Okay, so you should have enough tools now to be able to complete packet number 2. If you have any questions, send me a message on Remind or on Schoology.